E-commerce, also known as electronic commerce, refers to buying and selling of goods using the internet. Millions of transactions take place every day which can be used to find patterns in which people buy goods. This video will take you through a step-by-step scientific analysis of e-commerce transaction data collected over the period of a month from the activity of users on an actual commercial web platform for the same. Our dataset contains transactions from an e-commerce website from November 2019. It consists of the details of the items and at what time these items were purchased or viewed. Various operations will be performed on the dataset, which includes data cleaning, data preprocessing, hypothesis, visualization, exploratory data analysis, regression analysis, testing, and validation. Encoding of the categorical attributes is performed to use certain algorithms. Summary statistics and distribution tests are used under exploratory data analysis. Chi-square test is the statistical hypothesis applied which helps to decide if something was just random chance or not. Data is visualized using line graph, box plot, and histogram. Histogram was particularly used to prove the normal distribution. Various tests have been carried out to study the patterns in which the customer buys goods on the e-commerce platform. Let us now examine the dataset in detail. The dataset chosen for the analysis is an e-commerce behavior data from a large multi-category store. This dataset contains events of 285 million users from online websites. Data was collected using a behavior tracking system on large e-commerce stores. The dataset has been primarily sourced from Kaggle. The owner of the dataset is Michael Ekenau and is licensed by Data Files. All copyright belongs to the original authors. This file consists behavior data for 7 months, that is from October 2019 to April 2020. But for the purpose of analysis, a 2019 November dataset is being used. The dataset provides us the behavior data and the events related to products and users in the month of November 2019. Each row in the dataset describes an event. There were around 6 crore 75 lakh total rows present in the initial dataset. Coming to the columns present in the dataset, there are 9 columns. Event time attribute specifies when an event took place in UTC time and is of type object. Event type attribute consists of events such as view, cart, purchase and is of type object. Product ID is of type int. Category ID is of type int. Category code attribute defines the particular name of the category, that is, the product's category taxonomy if it is possible to make. Usually present for meaningful categories and skip for different kinds of accessories. This is of type object. Brand is of type object. Price attribute is the product price which is of type float. User ID attribute exists a unique permanent ID to each user which is of type int. User session attribute is a temporary user session ID. It is same for each user session. It changes every time a user comes back to an online store from a long pause and is of type object. We have a few libraries and APIs used. We have Pandas, which is a library for data manipulation and analysis, importing and managing datasets. Statsmodels.api, which allows statistical tests to be performed, and PyLab, which bulk imports matplotlib.pyplot. Let's move to data preprocessing. The dataset is read using the readCSV function from the Pandas library, which is usually used for data preprocessing and for input or output of CSV files. Among roughly 6 crore rows of the dataset, there were around 21 lakh rows with missing category code and 92 lakh rows with missing brands. Hence, the dataset was found to contain 57 lakh rows with null values in category code or brand or in both columns. Since there was ample data available for analysis, we dropped the rows having null values, after which the data set gets reduced to about 4 crore rows. Exploratory data analysis, also known as EDA. Several plots and visualizations have been performed in order to understand and highlight various real-world aspects and interesting features of the recorded data. Let's look at them one by one. Number of visitors by date. To analyze the number of visitors by date, we have grouped the dataset by the columns event, time, and user ID. The number of visitors each day is extracted and displayed in the graph below. We can see that there is a massive peak in the curve of 17 November 2019, which was a Sunday. Owing to the traffic on the site, we can tell that people are mostly free on Sundays to shop. Another possible explanation could be that Black Friday sales that take place a week or so prior to the holiday. In 2019, Black Friday was on the 29th November, which is roughly 12 days later, when the e-commerce website starts displaying sneak peek of all the offers that will be available during the sale. Next, we have most bought brand. The below pie chart shows the popularity of the brands in the market, with Samsung being the top brand. The getCmap function from the matplotlib module helps us achieve this. Conversion rates. As there are three types of events such as view, add to cart and purchase, it does not mean that every user who has viewed the product has added to cart or purchased it. Most of the users who visit the e-commerce platform might just want to view the item and its price, but not actually buy the item. Some users might add the item to cart or decide to pay for the item later. The conversion rate gives an idea of how many users actually purchase a product as opposed to how many times products are viewed or added to cart. Also an idea of how many products actually purchased as opposed to the number of products added to cart. We found the total count of people who just viewed the item, count of people who added the item to cart, and count of people who bought the item to find the conversion rate. The rate of conversion from view to purchase is just 1.67%. View to adding the item to cart for later review is 5.38%. And buying the item that is added to cart is 31.17%. By keenly observing the data set, we can also get to know that there are some cases where no carting data is recorded before purchase. So it can be concluded that sometimes customer can use the one-click purchase button to buy directly without a cart event. Brand-wise sales. The purpose of this visualization is to get an idea of which brands see more user engagement or activity on the site. All types of user events such as view, cart and purchase have been considered while plotting the first graph. As we can see, Samsung is the top engaging brand. To determine the brand with most sales in the market, only purchase events have been considered for the second graph. As seen in the graph, Samsung is again the top player in the market, closely followed by Apple. A number of brands with only one product sale, each including Cameo and Zepco, take the last position. Samsung saw 119.91% more sales than Apple and almost 1 crore times more sales than the bottom player in the market. Let's consider the purchase path. The standard idea is that most people first view an item, compare it with other items, and then add it to cart to buy the specific item. It is surprising to see that not many people follow this path. Either people may come to view the item and compare its specifications with other items and buy it offline, or they may have some item on their mind and buy it online without thinking twice about any other products. Storing the order details beforehand on the website is also a reason for many people to prefer shopping online than offline. Given below an example of a customer who actually followed the path of view, add to cart and purchase. User's journey. The first piece of code below shows as a user who purchased an Apple product and after the same he views other products made by the same company Apple. The second image shows us a particular user who views an Android phone, purchases the same and then goes on to view other Apple products, namely clock and phone. Adds the clock to cart and purchases it. Later views an Apple phones, maybe to sync with the clock he just bought. What inference can we draw from this data? You know how we all hear everywhere about how Apple customers swear by brand loyalty, sometimes regardless of the same or perhaps more advanced features being available with other brands at lower prices. Well, this score seems to show just that. The Apple customer has viewed only other products, while the Android customer views all kinds of brands including Apple. Popular product categories. A squarify plot is used to visually represent which categories of products have drawn more demand from the customers. Most of the items are given two category codes separated by a point. First word depicts the main category of the item, whereas the second word following the point depicts the subcategory of the product, which gives more specific meaning to the item. Unsurprisingly, smartphones, which come under electronic goods, are the most popular. As we can see, a huge fraction of the items bought are electronics or appliances. We may infer that there have been major discounts and price deals online as compared to the strict MRP rates in brick and mortar stores, which must handle a lot of other costs such as labor charges, store rent, building maintenance, transport of goods from warehousing to retailer, etc. But with the help of digitalized or online stores, a lot of these are cut down. Activity of users versus day of the week. The number of activity of users per day versus the day of the week graph has been plotted below. First, the day of week is extracted from the date in the timestamp column. This day of the week is used in x-axis. 0 means Monday, 1 is Tuesday, 2 is Wednesday, and so on. The y-axis consists of the total number of people who visited and bought the items on the specific day. Attracting more buyers. Look at the graph. There's a huge spike at day 4, 5, and 6, which means Friday, Saturday, and Sunday. It makes sense that discounted prices provide better gain for the seller when there is a large number of customers. So, with the knowledge from previously graphed data showing that more purchase events are recorded when the price attribute of a product drops. The e-commerce company can attract more buyers by reducing prices or offering special discounts on weekends. Distribution type. Predicting the type of distribution can be done in two ways. One is visually and the other is by test. Real-world datasets usually don't perfectly follow any particular distribution, but a similarity can be found. As mentioned earlier, the dataset has only one numerical value, that is, price, while the rest are categorical. Normality tests executed on price attributes are histograms and QQ-plot to visualize the data distribution, followed by the Kolmogorov-Smirnov test to affirm the same. The histogram is an excellent way to easily visualize a single variable's distribution. It gives us the frequency of occurrence per value in the dataset. Easily plotted with the hist function from the pandas library, the histogram shows a higher value on the left than the right. The theoretical bell curve shape can be seen. QQ plot stands for quantile versus quantile plot. This was so chosen as it gives a clearer understanding of the deviation from normal distribution than a histogram or count plot as it compares the theoretical values and the actual quantile values. The quantiles of our variable, which is blue, are exactly in line with the theoretical normal quantiles, which are red. A straight line on the QQ plot shows us that we have a normal distribution. The case test is the Kolmogorov-Smirnov statistic test in which, if the null hypothesis is valid, data follows a Kolmogorov distribution. The p-value we got as shown below is 0.2634, which is greater than the alpha threshold of 0.05 for 95% accuracy, which concludes a normal distribution. Preparing data. This is the most interesting part of data analysis on this set of records. What predictions can we make based on this data? The most interesting prediction for an e-commerce website or indeed any sort of business would be whether the customer shall purchase a product or not. The knowledge of what factors contributed to this decision may be invaluable for improving business strategies and sales. Here, we predict whether a product added to cart is actually purchased by the customer based on factors such as its category, weekday of the event, activity of the user in that session, etc. We add some new features into the training data set. Category code level 1 is category, then subcategory, weekday of the event, number of activity in that session, whether the put in cart item is purchased or not. Hence, the training data set contains every non-duplicated cart transaction with mentioned new features. We will use those features, including the original price and brand, to predict whether the customers will eventually purchase the item in the cart. First, using the pandas lock method, we obtain a list of records of all those who have bought or added products to cart. Then, we count all activity of the above users, including non-buying events, which can then be used to count the number of activities in one session. Next, with the help of some helper function, we extract the event date from the event time column and find out the weekday on which the activity occurred. Splitting of category codes into subcategory levels 1 and 2, as mentioned, is done by simply string handling. With the preprocessing complete, the data set is ready to be fed as input into machine learning models. For more convenience, we save the preprocessed data as a new copy. Resampling data to have equal number of purchased and non-purchased items. The number of rows where an item was purchased was around 5 lakh and the number of rows where an item was not purchased was found to be 8 lakhs. So, in order to balance the data set, the data has been resampled to contain an equal number of purchased and non-purchased item rows, which is exactly 5 lakh, making it 1 million rows in total. The preprocessing module from Python's sklearn data science library proved helpful for this task. Following, we have encoding categorical attributes. The categorical attributes in the dataset such as brand, event weekday, category code level 1 and category code level 2 have been encoded as integers with the label encoder object from sklearn so that it forms an acceptable input to machine learning algorithms. As you can see, values under these columns are all now numerical. Hypothesis testing for attribute dependence. Before actually diving in with the machine learning model, it is a good practice to check whether the features selected as the input vector mathematically influence the values of the target feature. That is, the target feature is dependent on these. Of course, with knowledge of the real world meaning and significance of the attributes or basic concepts of how the data is collected, such as the price of a product will vary with brand. So, it can be said that two are dependent just by examination. Associations, associations among the attributes can be identified. In data sets with unknown or ambiguous features or new areas of research, or just in general, it is used to mathematically or statistically check associations between various pairs or groups of columns in the data set as a sort of confirmation or perhaps discovery. Hypothesis testing is a well-defined and quantified way of performing such tests. We use the chi-square test to carry out hypothesis testing, taking up example cases of relation between categorical attributes. The first case is between weekday of the event and price. The null hypothesis was rejected based on the obtained p-value for this. The next one was between user ID and category. Null hypothesis was accepted based on the obtained p-value for this. Time series analysis. As you have probably realized by now, the dataset is time series, meaning it shows different values or events over a linear period of time at equal intervals. In this case, it is transaction events taken place over the period of a month recorded every day. We have plotted a small time series graph to illustrate the same. After passing the date and time columns with the dateutil module, we show the events per day for the month as a line graph. This helps us gain insights for application of further predictive models and in-depth analysis. Covariance and correlation matrices. Covariance matrix is a measure of how much two random variables get changed together. It is actually used for computing the covariance in between every column of the dataset. Covariance is a statistical tool that is used to determine the relationship between the moments of two asset prices. Built-in methods matrix.cov and matrix.core serve this purpose. A correlation matrix is a table showing correlation coefficients between variables. Each cell in the table shows the correlation between two variables. A correlation matrix is used to summarize data as an input into a more advanced analysis and as a diagnostic for advanced analysis. The color-coded heat map produced on output with the PyPlot library gives us an idea of the degree of correlation or interdependence between corresponding attributes. For example, as it can be seen along the principal diagonal of the matrix, every attribute is perfectly correlated with itself. Now we apply the actual ML models. First, the available data, which is selected input features along with the target feature is purchased, must be split into chunks for training and testing. This is done with the tool from Python modules. Train test split is the inbuilt function which is used in dividing the dataset into training and test data. It is a function in sklearn model selection for splitting data arrays. Next, various algorithms have been used so that we can derive a comparison of performance and better understanding of what kind of approach suits the peculiarities of our data set. Decision tree. Decision tree mining is a type of data mining technique that is used to build classification models. It builds classification models in the form of a tree-like structure just like its name. This type of mining belongs to supervised class learning in which the target result is given. In particular, decision tree works well when you have features that are on completely different scales or a mix of binary and continuous features. Why choose this algorithm? A decision tree is used when the data set has a mixture of continuous and categorical attributes. The purpose of this machine learning exercise is to predict whether a product is purchased or not. This final target feature is binary. It depends on both categorical attributes such as brand, category code, event weekday, as well as the continuous attribute price, which is most important. While a decision tree is being built for a dataset, it calculates the most accurate split based on each node at each step. A continuous attribute, if encountered, is usually split by keeping some kind of threshold value as the delimiter. The decision tree algorithm is completely invariant to scaling of the data. Thus, it works well for the huge data set with a dimensionality that is not too high, which is many rows but few columns, just like this. As each feature is processed separately and the possible splits of the data doesn't depend on scaling, no preprocessing like normalization or standardization of features is needed for decision tree algorithms. The main downside of decision tree is that even with the use of pre-pruning, they tend to overfit and provide poor generalization performance. As we can see in the output box, the decision tree algorithm classifies purchasing on our dataset with an accuracy of about 67%. Hence, we try the next algorithm. XGBoost classification. XGBoost is an ensemble ML algorithm that offers high performance and scalability powers. Ensembling is a machine learning technique that involves combining several machine learning models to build a single powerful predictive model to get optimal results. Boosting is an ensemble-based learning algorithm that converts weak learners to strong estimators by training ML models sequentially one after the other. In each iteration, model tries to correct the error made by the model in the previous iteration. This model uses gradient boosting approach. XGB classifier object is imported from XGBoost model. The function fit and predict are used to apply XGBoost on the given dataset. Inbuilt functions are used to calculate important performance measures such as accuracy, precision, recall, and F-beta. Why choose XGBoost? X should consider using XGBoost for any supervised machine learning task that fits the following criteria. You have a large number of training examples, more than 10,000, and few features. In general, as long as the number of features in the training set is smaller than the number of examples. XGBoost also tends to do well when you have a mixture of categorical and numeric features or just numeric features. With the advanced training or learning features, we expect a higher accuracy with this model as its suitability features match the dataset quite well. However, as seen in the output box, the accuracy of predictions made by this algorithm is comparable to that of decision tree at around 68%. So, we try one final machine learning algorithm to compare prediction accuracy. Logistic regression. Logistic regression is a statistical model that in its basic form uses a logistic function to model a binary dependent variable. It is used in regression analysis as a form of binary regression. The logistic regression function, also called the sigmoid function, is an S-shaped curve that can take any real valued number and map it to a value between 0 and 1, but never exactly at those limits. Logistic regression uses an equation as the representation, like linear regression. Input values are combined linearly using weights or coefficients value to predict an output value. Input values are x, output values are y. A key difference between linear regression is that output value being modeled is a binary value, that is 0 or 1, rather than a numeric value. Why choose logistic regression? Logistic regression is a tried and tested classification method. It is used to predict an outcome variable that is categorical from predictor variables that are continuous and categorical. Normal linear regression cannot be used because having a categorical outcome variable violates the assumption of linearity. Logistic regression deals with this problem by using a logarithmic transformation on the outcome variable, which allows us to model a nonlinear association in a linear way. As seen in the output box, logistic regression on the dataset predicted purchase events with an accuracy of 53%. We identified a substantially large and potentially interesting dataset with the added novelty of it being a time series. We cleaned up the data and set to work tackling its peculiarities. We performed various kinds of basic visualizations to understand the properties of the data, then did some more advanced analysis for a deeper understanding of its meaning. This also gave us insights into the behavior of the real-world generators of this data, that is, human customers on the site. We then got down to prediction with machine learning. This involved a whole lot more of preparing the data and formation of new features from the existing ones to better suit the model. After some preliminary correlation and associativity analysis, we applied three different algorithms in the same scenario, getting different accuracies for each. All in all, a complete and thorough data science experiment was carried out. We hope it made an insightful viewing experience.